So here is arguably the best mousetrap ever made. Now let's set it. And along comes a mouse. And let's say you didn't hear that because you were at work or asleep or something like that. So let's build a circuit that will tell you that the mousetrap has been sprung. So when the mousetrap is set, you have continuity from this point here and this point here. So when the mousetrap has been released, that continuity is no longer there. So what you can do is solder two leads, one here and one here, and set up a circuit to sense when there is no longer continuity between those 2 points. So let's go ahead and do that. So when you want to solder this all together, you want to make sure that you have your solder joints as close to the wooden board as possible so they don't interfere with the hinge mechanisms. Now let's test the continuity. So I have my DMM set to beep when continuity has been established between those 2 points, and it's beeping, so that's good. Now it's possible this little arm here could fall onto the spring, but it doesn't set off the continuity because the resistance is too high between these 2 points, because this is just free floating within the trap. So here's a very simple circuit you could use. All that's involved is a PNP transistor, a red LED, and 2 resistors. Also a 3-volt power source. So you could use a coin cell to replace the power source I'm using. So when it's set, the trap that is, the light is out, and when a mouse comes along and sets off your trap, the LED turns on. So you could mount that LED somewhere visible, more visible than the trap, so you would know that the trap has been sprung. And just to show you the efficiencies of this circuit, right now when the LED is off and the trap is set, it is at 3.26 milliamps. And when the trap is released and the LED is on, it's pulling 11.41 milliamps. So the current's pretty low. So it should last a while with just a coin cell powering the system. So here's the schematic of the LED indicator for the mousetrap. You can see that I have 2 resistors, 1 diode, which is a red LED, and a PNP transistor. So the mousetrap is connected from the emitter to the base of the PNP transistor, so when the mousetrap opens, it is no longer tied high, it will go low through the 1 ohm resistor. So you may need to play with the values yourself, but that should work. So future designs of this that I will make will incorporate a speaker, so you have an audio indicator that your mousetrap has been sprung, and also I'm going to attempt to make something to send you an email telling you that your mousetrap has been sprung. So stay tuned for those. Thanks for watching.